welcome back to my channel, myself Sorbi, and very good afternoon, good morning. And today I'm going to start the topic about the periodic classification. And I took one topic from that is nowadays students struggling a lot how to find the screening effect and what is screening constant, what it mean, what is nuclear charges, how this periodic modern periodic table depends upon. So, without further delay, I'll start my topic about what is screening effect. Before I jump to the topic, I want to give a brief introduction about the periodic table. In my upcoming videos, it will be there, but before I jump directly to the topic, I'll give a brief introduction about that. So, as you know that in the modern periodic table, how many groups and how many periods we have? So we have 7 periods and 18 groups. As you all know that, if you don't know that, I'm here, don't worry about that. So where the periods shown, that this is called 1 2 3 4 5 6 7, total 7 periods we have, and group we have 18 periods. How will you calculate it? So you will calculate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So how many total periods we have? Total period 7 and group we have 18. So according to that, in there it is written that what is alkali, all the what is metalloids, what is actinoids, what is alkaline halogens, other transition noble, and so on. So I'm not going to discuss right now what is that, but I'm going to discuss about the screening effect. First, you know that in the periodic table, modern periodic table, we have basically we have C. If we'll take the group 1. So as you know that, so we are, how we will remember that? In group 1 we will remember like Helena ka rab se faryad. हेलिना का रब से फरियाद, दैट मीन्स हाइड्रोजन, लिथियम, सोडियम, पोटेशियम, रुबीडियम, सीजियम एंड फ्रांशियम. Actually francium we are not taking because it's a radioactive elements, but for remembering you should go for that. Now if you know that down the group, if we'll go from top to bottom, what will happen? We know that atomic size increases, right? Ma'am, how could you say that? How will you say that atomic sizes increases? So you know what is the atomic number for lithium? It's 2 comma 1, that is 3, correct? Now if we know about the number of shells is how many shells are involved to fill that electron. So we have 1 and 2, so number of shells is 2. Now if I'll go for sodium, atomic number is 11, the atomic configuration will be 2 comma 8 comma 1, correct? So number of shells will be 1 2 and 3, correct? Now similarly if we will take the atomic number, potassium K, what is the atomic number? Is 19. And how we will write that? 2 comma 8 comma 8 comma, what is that? 8 to 10, 18, 1. That is number of shells, and again increases. For lithium number of shells is 2, sodium it's 3, potassium it's 4. So number of shells are increasing down the group. And due to that, अगर number of shells increase होगा, then what will happen? The suppose you know that nucleus इधर है, okay? And if number of shells, number of electrons are present here, if the number of shells increases, the distance between nuclear to the outermost electron distance automatically increase होगा, yes or no? Obviously. अब नंबर ऑफ शेल्स जब इंक्रीज हो रहे हैं, नंबर ऑफ जो डिस्टेंस है आपके न्यूक्लियर से लास्ट इलेक्ट्रॉन का वो इंक्रीज हो रहा है, तो ऑटोमेटिकली जो अट्रैक्शन होगा आपके न्यूक्लियर से आउटर मोस्ट शेल का वो डिक्रीज होगा, अब आप मान लो एक एग्जाम्पल, फर्स्ट कम फर्स्ट सर्विस। अगर जो फर्स्ट आप टीचर आपके क्लास में पढ़ाती है, जो आप फर्स्ट बेंचर हैं, वो जितना ध्यान से पढ़ेंगे, अगर इंटेंसिटी आपकी वॉइस की, आपके मैम की वॉइस की सेम है और काफ़ी लंबा क्लास है, जो लास्ट बेंचर्स होंगे उनको कम वॉइस सुनाई देगी। सिमिलरली जैसे जैसे आपके नंबर ऑफ शेयर्स बढ़ रहे हैं, यहाँ पे स्क्रीनिंग इफेक्ट बढ़ रहा है। बेसिकली स्क्रीनिंग इफेक्ट को हम लोग क्या बोलते हैं, एक तरह का शील्डिंग इफेक्ट बढ़ रहा है। जो इलेक्ट्रॉन और न्यूक्लियस का जो आपका जो कैपेसिटी अट्रैक्ट करने की है वो डिक्रीज हो रही है। व्हाट वी अंडरस्टूड, एटॉमिक साइज इंक्रीजेस, शील्डिंग इफेक्ट डिक्रीजेस डाउन द ग्रुप। सो as you know that, now you hope you understood about the screening effect. Number of shells increase होगा, number of shells increase होगा automatically, increase होगा, shielding effect decrease होगा. Don't forget that it will be decrease. Now what will happen now? After that, मैम हाउ वी विल फाइंड द स्क्रीनिंग इफेक्ट, मतलब स्क्रीनिंग कांस्टेंट कैसे हम निकाल सकते हैं, हाउ वी विल फाइंड। सो फॉर दैट आई हैव वन फॉर्मूला फॉर दैट। सो सपोज दिस इज द न्यूक्लियस, सपोज दिस इज द न्यूक्लियस एंड अलॉन्ग द न्यूक्लियस अगर मैं लिथियम का काउंट करूँ तो हाउ मेनी लिथियम, एटॉमिक नंबर इज 3, number of shells 2, 1, so we have basically two shells, right? K shell and L shell. So one shell, two shell. Now you have one formula for, सबसे पहले screening effect constant we will represent as sigma. After that number of shells, what we have, two cells. तो फर्स्ट सेल किस सेल का हम निकाल रहे हैं, लास्ट शेल का, न्यूक्लियस से लास्ट शेल का. So except that, how many electrons we have? We have two electrons in different shell, not that same shell. तो उसके लिए हम क्या करते हैं, we have formula. जो हमारा फर्स्ट शेल होता है उसको हम लोग लिखते हैं 0. जो फर्स्ट शेल हमारा होता है उसकी जो वैल्यू होती है हमारी 0.35, करेक्ट. जो सेकेंड शेल होता है उसके लिए जो वैल्यू हमारी होती है वो होती है 0.85. और थर्ड अगर सेल आप में तो एक्सेप्ट ये दोनों, बाकी के लिए हम काउंट करते हैं 1. सो फर्स्ट सेल, दिस वन जो लास्ट होगा, एन सेल, एनएच सेल, दैट इज वैलेंस शेल. आफ्टर दैट वी विल कंक्लूड एज n-1 shell, and after that we will kill as whatever be the number of cell, we will multiply by 1. So we are calculating for lithium, right? So for lithium atomic number is 3, 2, 1. So for what we are calculating, so is for first cell we are not calculating, for valence shell we are not calculating. So for the valence shell, what is the value for that? I told you that 0.35 we will not include. So second cell n-1 value we will include, that is 2 into 0.85. So after calculating you will get the value approx 1.67, 1.7. So screening constant sigma value for lithium is 1.7. Easy peasy. Yeah. Now suppose I want to write for sodium. So solve sodium atomic number is 2, 8, 1, 11, right? Now calculate for that. Now this electron now the previous was about the lithium and sodium. Now if we'll take the example of that second group, that is helium, or second, if we'll take that second period, then what will happen? We have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Then if the last shell is having one shell, it is okay to calculate. Suppose I'll take the example of beryllium. What is the atomic number? Atomic number 4. Electronic configuration is 2 comma 2. Now for that, how we will find the screening constant? Now here, the last shell we have 2 electrons. So for last cell 2 electrons we have. So total screening constant for how many electrons we need to find? 3, because for the last 1 electron we are not finding. We are taking the last electron as a reference, and except that all for all we need to find that screening effect. Similarly, if we'll take the example of boron, the atomic number is 5, the boron is having 2 comma 3. So how many, for how many electrons we need to find the screening effect? It's for 4. In 3 last electron we will not find, so we will find 2 comma 2. For 4 electrons we will find the screening effect. Similarly for the all the elements. Now for the beryllium, how we will find? Then we have told you that for the first shell, here first shell having 1 electron, then the value will be 0.35. How many electrons left? We have 1. Plus, now n minus 1 cell, 0.85 into 2. Correct? Now after calculating, we will get the value of 2.40. So for beryllium, the steric electric screening constant will be 2.40. And try for me, for you all,